Hello, everyone. I will talk today about serverless edge computing. So thank you for introducing me at the beginning. My area of research is Internet of Things. So simply, okay. So simply in IoT systems, Internet of Things systems, we have a continuum composed of consisting of IoT devices on the lower layer in this kind of system. So smart cars, smart meters, robots, and this kind of equipment. And we have a cloud for computing and processing all the data from the IoT devices. And somewhere between we have edge computing. So this is the layer that we can process the data. We can move some computation from the clouds to the edges to process the data and to increase the response of the system. Nevertheless, the problem is that this kind of solutions are quite complex in architectural design from hardware point of view, because we might have different communication technologies from IoT devices to the edge and from the edge to the cloud. So we might have such technologies like Zigbee, Bluetooth connectivity, mesh networking like open thread communication between the sensors and the edge devices. Then from the edge to the cloud, we might have simple fiber connection, Wi-Fi connection, or we might have low power WAN connectivity like narrowband IoT, which is somehow at some point unreliable for sending the data and with very low throughput. And of course, we might have also IoT devices connected directly to the cloud using narrowband IoT connectivity. So the infrastructure for processing the data in this multi-layered continuum is quite complex. So it's not as easy that we have different components and the fiber connectivity between the components, and that's all, because we have different type of technologies, different type of devices. Then when we talk about the edge computing and the devices, here on the slide, we have some devices from NVIDIA. So we might have enterprise solutions dedicated for some containers located near the BTS stations from the GSM providers in edge computing centers in 5G technologies. Then we might have smaller kind of rack servers with some GPU cards for industrial automation and processing, for example, the streams of video data from the cameras located at the factories. And finally, we might have embedded edge clusters composed of Raspberry Pis, NVIDIA Jetson Nano, and this kind of devices just to process the stream of data in some cafes, shops, small houses, or small factories where we do not need the industrial capacity of processing. So at the end of the day, we have very complex infrastructure with the cloud providers, IoT devices, and different types of edge computing capabilities and different type of devices. So the question is how we can organize the processing of the streams of data, sensor data on this kind of infrastructure. One of the idea is to use concept like osmotic computing, where the services that process the data, called in this nomenclature, in this case, microelements, can migrate and can be moved between some environments, so between clouds, edge, and IoT devices, and trying to self-organize itself to make the number of processing and the trying to self-organize and adapt to the particular current technical infrastructure between the environments. So in this case, we might think of some sort of slider, but we can move the particles, in this case, services, from the clouds to the edges or to the IoT devices, changing the way and how the data are processed, where the data are processed, and of course, the final quality of processing and the response time of the system. So when we need high responsiveness of the system, we can move all the particles, all the services to the IoT devices. In other case, we can move to the cloud. And of course, implementation of this osmotic computing in real life, in simulation is easy. We have some simulators for osmotic computing, but in a real life, it's quite complex. So let's think of that fog flow pipeline. So it's a sort of graphs representing how the streams data are processed. It's like in a Node-RED solution, probably you know how it works. So the problem is how we can map the services of these data flows to the current infrastructure to process the data. Currently, I'm working on the implementation using Knative way of making a serverless computing. So the idea is to make the processing services as functions in a Knative, which would be driven by eventing, representing the flows between of the data between the processes. So we think that Knative might be a way of implementation of this pipeline processing of the stream of data. And of course, the research problem is how we can map the services as a code to the particular devices. So we have to follow some process. First, we need to define the processing, like with the camera, where we have some streams or video stream. Then we have some services to process this data. So we have to provide this information. Then we have to decompose it to different devices. Then, depending on the available execution environment, we have to prepare some ensembles and deploy on the devices. So it's quite easy when we talk about it. We have some solutions for doing it, and it should be quite okay. But the true problem is that the IoT systems are very dynamic. They have to handle some disturbances that might appear and some failures that might appear in the system. So that's why instead of doing the serverless implementation of this fog flow and osmotic computing, we are trying to handle the problem of adaptability of this kind of systems. So we think that these systems should be adapted to the runtime context, should be resilient to failures, and should have some way of predictive maintenance aspects included in the system. Of course, there are some challenges in this case, how we can assess the quality of processing of in such heterogeneous systems. What techniques and methods can we use to detect the deterioration in the performance of processing in this kind of system? How we can automate the process of self-healing of the system? And can we run these algorithms on resource-constrained IoT devices? Of course, to solve this problem, we have to use some techniques. Till now, we are investigating the reinforcement learning algorithms where we have exposed different...
Ja, ik moet wel gaan, man. Dus...
Oké, ik maak nog even af, dan je het vanzelf wel.
Okay, well, probably it's not a question to me. So we have exposed several switches and gauges and sliders from different layers, which were modified and adapted using reinforcement learning algorithms. So as a input, we get some metrics from different layers of the system, and this agent tries to optimize the behavior of the whole infrastructure by rerouting the events between services. Then we thought that we shouldn't have a central agent for the processing, so we need to implement and design the distributed way of communication between autonomic agents deployed at different on different IoT devices, on different edge devices in the cloud. So we think that these nodes should communicate between themselves and try to figure out the common goal for the whole infrastructure, how to adapt to the changes and to the disturbances in the execution environment. And finally, to show some examples of these problems aspects that this system should handle is use of renewable energy sources. So how to reroute the processing of data streams in the way to use the most of the solar energy as we can provide. So simply we should reroute the video streams to the more sunny edge locations before moving this processing to the cloud. Then we have
Tomasz, sorry to interrupt. Kind of over time. Can you just wrap up quickly, please? Maybe
yes.
Conclusions.
Yes.
Thank you.
Then the second problem is anomaly detection and detecting how the edge devices deteriorate in the quality. And the last thing is the adaptive monitoring. So we can't expect that we can use the Prometheus to monitor all the IoT devices and edge devices in the field. So we have to optimize the way how we can send the data from IoT devices to assess some failures in the system. And to sum up, we think that to implement the continuum of the cloud edge and IoT systems, we need some sort of adaptability introduced in this kind of systems, but we can't do it without doing out of the lab deployments. So we need to put these devices in the field. We need to, of course, get some requirements for this kind of system from interdisciplinary IoT projects, because it's for application types of projects. And of course, we need collaboration with industrial partners and IoT designers and vendors, because we need to handle some IoT protocols, real life protocols from IoT devices on the market. So this is our view on serverless, adaptive serverless edge computing for IoT systems.
Right. Yeah, thank you so much, Tomasz, for the talk. Very interesting and great to see kind of real life applications and use cases here. Yes, we're out of time. So if people have questions, please post them on Discord or on the Zoom chat.
Or offline, via email.
Yes,
yeah.
Yes. Okay. Or email Tomasz directly.
Mm-hmm.
Okay. Thank you.